so I'll start now. So welcome to lesson 4 of my refresher course. Today we're going to be talking about coordinate geometry. So we'll be talking about lines and circles and so on. Yeah, okay, so we'll just do a quick warm-up to get going. The first one is asking, we're going to check to see which one of these statements are true, right? So the slope of the line that goes through 0, 0, and 2, 4 is equal to 2. Does that make sense? Or how to think about it? What would that mean? Slope of the line is like y2 minus y1 over x2 minus x1. That's m, right? So it would be, let's say this would be x1, y1. This would be x2, y2. So it would be 4 minus 0. Y2 is 4. Y1 is 0. 4 minus 0 over 2 minus 0. That's 4 over 2. That's 2. That's right. Okay. The midpoint of 2, 6, and 4, 10 is 3, 8. Does that make sense? Well, to get the midpoint, we have to basically average the x's. So halfway in between 2 and 4 would be 3. Halfway between 6 and 10 is going to be 8. So that also makes sense. So these two are both correct. The distance between 0, 0 and 3, 4 is 6. Now we just sort of plot those there, 0, 0, and 3, 4. This is 3, 4. And there's 0, 0. So we're talking about that distance there. The question, is it equal to 6? Well, if we have a look here, that side would be 4, that side would be 3. So this would be a 3, 4, 5 triangle. So the distance would actually be 5. So that's wrong. And then a line perpendicular to 2 also has a slope 2. Now that's not right. When you have a line, let's say M1, the slope of line 1 is 2. Well, we're going to write that as 2 over 1, right? And then M2 is invert that and change the sign. Right? So that one's also wrong. So just quick warm up before we get started. So what we're going to be doing is coordinate geometry of the line and coordinate geometry of the circle. And we're going to have these pages in the formula book, which are it's kind of deceptive. Like we have a page full of formulas. So you think, okay, great. This is going to be like, whatever, super helpful. I'm going to have to do less work with this one. But nonetheless, they have a way of making these tricky. And the way in which they kind of make them tricky is basically in every question you do, you'll probably have to use 2 out of 2 of these formulas. Like, so this is a question where they give you a lot of tools to solve it, but you really kind of have to, let's say, be able to kind of slow down and kind of think about what you're being asked and things like that. Now, what I want to do today is go through these formulas, basically kind of explain how most of them work, let's say, and then just start to apply them. So we're going to have formulas for the line, and we'll have formulas for the circle. Okay. So here again, so if a line has a slope of 2, what is the slope of the perpendicular line? So that's what I just did. So if M1 is equal to 2, well, we're going to call that 2 over 1. The perpendicular line M2 is going to be equal to, you invert that, and then you also change the sign. So if M1 was equal to minus 3, we call that 3 over 1. M2 would be equal to, invert that, then it's 1 over 3, and change the sign from minus to plus. What we need every time is when you multiply the 2, when we multiply the 2 slopes, that afterwards they end up being equal to minus 1. Okay, so that's a formula, but it's not, it's the one formula in this section that isn't given on this page. Okay, so that's the one that you have to remember. And then another question is like, how is the slope connected to the angle? And this is where we get more into the formula. So if you think about slope, it's rise over run. And you can always think about slope in terms of a triangle, right? So what we're saying, rise over run, we're always thinking about like, going from like this point here to this point here. So if we go from this point here to this point here, well, in the act of going from that point there to that point here, you go up. So you have a rise, and you also have a run. And you see, it makes like you want this to be not some sort of like just something that you learn off by rote. What I do sometimes is I think of steps of stairs. So imagine if you have some normal step of stairs in your house. It's sort of not exactly the case, but let's say it could be for every step you go forward, you go an equal amount upwards. But then you could have like the steps into your school, which might have a longer type of, they might be longer like this because maybe people are sort of queuing or something. Or else you might have a ladder, which is sort of much, much more like this. So what's happening in each of these cases, like as we step along the set of steps, what's different is that the amount that we go up in comparison to the amount that we go across is changing every time. And if we were to take the fraction of how much you go up over how much you go across, this is what the slope is. It just gives you a measure of how pitched it is. But something else that gives you a measure of how pitched it is the angle as well. So this question is like, how is the slope m? How is the slope connected to the angle? And what we see is, you see m is equal to rise over run. But here's another formula. And we're going to do this tomorrow. Tan theta is equal to opposite. So this is over adjacent. So basically m is equal to the tan of the angle always, okay? So it's just, we're not using trigonometry here in the coordinate geometry section. So it's just sort of like we'll be doing sine, cos, and tan tomorrow when we look at trigonometry. But one thing that tan theta gives you is it gives you, and like if you're in a triangle like this, then the opposite is much longer than the adjacent. So the opposite over the adjacent will be bigger than 1, for example. But if you're in a triangle like this, then the opposite over the adjacent, well, the adjacent is much longer than the opposite. So the opposite over the adjacent will be less than 1, right? And what those things are is that's tan theta and that's tan theta. So these things are connected together, okay? And there is a formula in the book which is it given to you? I don't think it is. It might be one of the ones that's not given to you. But there's another one where if you're given 2 lines and you have the slope of the 2 lines, then you can get the angle between the 2 lines. Okay. So yeah. Okay. So the key idea of coordinate geometry is we're basically going to be about like turning these pictures of lines and circles basically into equations that we can work with. So we'll have a picture, we'll have 2 points, we'll know how far they are away, we'll know how far a point is away from a line, we'll know what the center of a circle is, and this will enable us to do, there's all these different things that we could sort of use these for. Like you could imagine, I don't know, like planes flying through the sky and where they're going and so on, right? So we're going to do, for lines, we're going to be looking at slopes and we're going to look at intercepts. So one thing that we care about lines will be like, if this is a line, this is where, see, this is an intercept. So we care about these things. And we don't only care about the intercepts of lines with the axis, we care about the intercepts of lines with other lines as well. And we care about the intercepts of lines with like circles, for example, as well. So and then speaking about circles, what we care about with circle is being able to find the center and being able to find like the radius. And we might want to say like, is a point inside of a circle? Is the point outside of a circle? So we're going to be, what we have with coordinate geometry is a way to kind of link these sort of pictures with algebra sort of stuff. So it's like a bridge between the pictures and algebra kind of thing. Okay, so I have a piece of graph paper, which I assume that I want to use for this page here. Okay, so the first formula, I want to actually do the slope formula and the equation of a line formula first. So let's just do those two. So let's have a look at this first formula here. Let me just I'm going to copy this. Okay, so let's have a look at the slope of a line formula. So the slope formula, m is equal to y2 minus y1 over x2 minus x1 when it's something like this, right? This is like my first point, x1, y1. This is my second point, like x2, y2. And as I've already been saying, the slope is the rise over the run. And rise over run is like, okay, that makes sense. We get what we mean by that. But what we're saying is like basically in going from this point to this point, well, we rise up by this amount. That's our rise. And our run is in this direction. Okay. But if we consider our rise once more, well, the bottom level of our rise is that coordinate, is y1. And the top level of our rise is y2. And y1 is the distance from here to here. Y2 is the distance from here to here. So the distance from y1 to y2 is y2 minus y1. And then similarly, if we were to look at like, this point here corresponds to being here on the ground. This point here corresponds to being here on the ground. So then the run then is like x2 minus x1. So you see rise over run is just y2 minus y1 over x2 minus x1. So that makes sense. Now, the next thing that I want to work on is let's consider the same formula again. Oh, sorry. So let's consider the same formula again. And this time, what we want to do is I'm going to make a line to connect these two. Something like this. Okay. And this time, what I'm going to do is I just want you to kind of ignore that one. 1 second. I just want you to kind of ignore that second point. And I want you to imagine, we're going to call it a general point on the line, x, y, right? And this general point, this one is, let's say this one's fixed here. This is like a fixed one. But this general point could like slide up and down the line, right? So let's say it was there. Well, this would be our rise and this would be our run. But let's say it's here. Well, then this would be our rise and this would be our run, right? But if we go from here to here, that's our slope. And then if we go from here to here, like that's our slope, right? So what I'm saying is that we always get the same slope, regardless if it's going, of where that second point is, we'll get the same answer. So this second point, which we called x2, y2, a specific point last time, I want you to imagine as an xy that can just slide up and down the line, even go down here, like it can just, and we never change the slope. Okay, so that would mean that m is then equal to not y2, but y minus y1 over x minus x1. And then I'm going to multiply across m times x minus x1 is equal to y minus y1. And then that's going to give me that y minus y1 is equal to m times x minus x1. Okay, which is this formula here is the equation. So this is the equation of a line formula here. Now, the equation of a line formula is given in two different forms. The first form is like this. The second form is y is equal to mx plus c. Now, how are we getting this one to begin with? Well, we could be told that a line has a slope, m is equal to 2, and it goes through the point, like, we can say the point that it's going to go through is going to be like, let's say the point 2 and 3. And now y minus y1 is equal to m times x minus x1 is going to be y minus 3 is equal to 2 times x minus 2. And this is the equation of a line. We could stop here, but we could also like multiply it out and just get y on its own on one side and have no brackets left. Like, why would you do this? Let's say for now, the only reason to do this is that it's not wrong. Okay, we're just gonna do that. Okay. So I'll say y is equal to, multiply that out, 2x minus 4, and then this is a plus 3. And then I have y is equal to 2x minus 1. Okay? So now I have it in this form. I have it in a form that y is equal to mx plus c. So the slope, m is equal to 2. And then c is equal to, see, that's a plus c is equal to minus 1. So that's c is equal to minus 1. And so what we can do then is we can actually draw an xy axis. And this c is the y-intercept. So we can go down this side, it's minus 1 there. This is plus 1, this is plus 2. So we can start here. And then let's say this is 1, 2, 3, 4, 5. we can start here and then we can sort of draw an arrow. So this goes, m is equal to 2 means that you go up by 2 steps for every 1 step that you go across. So this here, you see, would be my m. So let me just sort of, so this then, that's another way to kind of get the line. So in one case, you're like, okay, I have my, my slope, I have my line. Now, how do I recover the line? But now it's sort of like, I have my line. How can I read off some interesting stuff? So it's the same thing, but like, it's the same thing presented in a slightly different way. Okay, so we are getting there, almost there with what we want to talk about with formulas. So the next one I want to talk about is the distance formula. So the distance formula, let's call it d, is equal to a big long square root symbol, and then it's going to be this horrible thing, x1 or x2 minus x1 squared plus like y2 minus y1 squared. Okay, so again, we have the same situation here. Now this side here, that was x2 minus x1. And this side here is like y2 minus y1. Let me put little brackets around that. And this is actually a triangle, isn't it? And it's a triangle and it has a right angle here. And now if I was going to look at this triangle here, let me call this side here C. Let me call this side here A. Let me call this side here B. Then I know from Pythagoras' theorem that because it's a right angled triangle, that this side squared plus this side squared is equal to the hypotenuse squared. So, C squared is equal to A squared plus B squared. And then we can also say that C is equal to the square root of A squared plus B squared. Okay. Well, I know I'm changing around now. Now let's imagine that C now. We're going to think of that C now as a D, as in the distance, okay? I just mean ABC because sometimes when we talk about like, Pythagoras theorem, we always use ABC, right? But now we're thinking about, like, there's no difference. It's just a little thing to jog your memory a little bit. So D now for distance. So that D there is going to be equal to a big square root. I'm going to match this now, like equal to a big square root. And then A squared. But A is this x2 minus x1 squared plus y2 minus y1 squared. Okay, so so this is what I'm saying here is that the distance formula is just Pythagoras theorem, and it's Pythagoras theorem written in a slightly different way because we're in a different sort of topic. We're in coordinate geometries, and we're not thinking about the lengths of sides. It's just like, here's a triangle and this side is 3 and this side is 4. So we're actually no, we have points. So we have to find out what the lengths of side are from subtracting like the x coordinate from the second x coordinate, from the first x coordinate or whatever. Okay, but it's just Pythagoras theorem written in a different way. Okay, and the next one I want to do is the following. So now imagine I want to find here, I have this sort of line segment here between these two, and I want to find a midpoint halfway in between. And I have that this is x1, and I have that here is x2. And I want to get this midpoint. Well, it turns out the midpoint, it also happens to be in the middle here. So how do I get the middle? Well, I just take the average of those two. So I just add them up and divide by the number of numbers. And then that's the same over here. So the midpoint then, the midpoint is x1 plus x2 over 2, y1 plus y2 over 2. Okay, now let's have a look here what else we have. Which ones have we not? Oh, wait, hold on. Okay, so we've done like this one, this one, this one, these two. Now this one here, the distance from a point x1, y1 to a line x2, y2. So that distance formula, so we have a line, and the line is given by ax plus by plus c is equal to 0. So we would have to write the line with everything brought to the left-hand side. And then if we have a point x1, y1, then the distance, and what they mean by the distance is the shortest distance. So that's the perpendicular distance from that point. Like you could go from here you can go from this point to the line in this direction or in this direction. In fact, in any number of different directions, but there's only one that's the shortest, and that's the perpendicular distance. And that distance, which we call d, is this following kind of formula. It's basically the absolute value ax1 plus by1 plus c all over the square root of a squared plus b squared. If you want to know where it comes from, it's basically you'd learn it in like first year in college, right? So some of these formulas you don't need to know where they come from. These absolute values, you see, the reason for these absolute values is because distance is always positive, right? Like you wouldn't say like, the distance from your house to whatever, one shop is like 5 kilometers, but if there's another shop that's in the opposite direction, you wouldn't say that it's like minus 3 kilometers, right? You'd say it's 3 kilometers, right? So when we talk about distance, we don't care about the sign. So these goalposts here, like these bars here, are just a fancy way of just saying, give me a plus out of this, okay? And then that's a square. So we would have to have the line, so we would have to have everything on the left-hand side, and then recover the coefficients A, B, and C, and then sub them into this formula here. And then we have a triangle formula. Now, here's the triangle formula, and students make mistakes with this all the time, and it's just sort of painful to see it because it's such a small mistake, and I don't want you to make this mistake, right? So this is the formula. Again, I can't, like, I was able to derive the previous formulas, but just showing you, these diagrams and stuff. I can't derive this formula here, right? You have to, it's easy, but it's just, it's just further study, right? So you do it if you were to do maths or something in college, you would do it. But if I have a triangle, like let's say with 3 points, like this, let's say, no, let me do it a little bit better. So here's my 3 points for my triangle. Here's my triangle. So I have, this is going to be like let's say, this is going to be my x1, y1. This is going to be my x2, y2. This is going to be my x3, y3. I have this formula to work out the area of the triangle, and this is it here, right? So see, it's a half x1, y2 minus x2, y2. Now, the mistake that students make is they just go along and they take the point x1, y1 and they just sub it in. And then they take the point x2, y2 and they just sub it in. And they do a lot of work, but they only get a low partial credit, so they only get three marks out of 10. Why is that? Well, the reason is that you can only apply this formula after you've done a translation. And what's a translation that you need to do? So you have to move one of the points of the triangle. I usually pick the closest one. You have to move that over to the origin. So we would have to go to each of them and move them by the same amount, okay? And then you get another, this is actually your x1, y1, and this is actually your x2, y2. So even though, see, it's the same triangle with the same area, again, but just one of the points, it doesn't matter which one. So what we do is we just draw we draw x3, y3, whatever that was, and we do an arrow to 0, 0. And then what we're going to say is well, imagine that point there was, let's say it was like 2, 3. Well, in order for 2, 3 to get to 0, 0, we have to subtract 2 from the x and subtract 3 from the y. And then we just have to do that for x1, y1, and x2, y2 as well. Subtract 2 from the x, that's called translation. So you just have to shift the entire triangle by doing this translation to all the x values and the y values as well. So that, and then once you've done that, then you can apply the formula. Okay, so that's just a tricky point. And then this one here is another one that we don't really have. It's called the dividing a point into. So you may this one here is about getting a midpoint, so getting right in the middle of the two. But you might want to be down one end. So if I was going to balance like this pen that I have here on the end of my finger, if I put it right in the middle, it'll probably fall down. So I have to kind of find the center of gravity. So it's about dividing it not in half, but maybe 2/5, 3/5. So what we'll have is like the A and B will be ratio. Maybe that'll be 2:3. And it's a little bit tricky of choosing which one is the 2 and which one is the 3 and which one goes where. So we'll see that in a minute. And then the next one is about circles. And I'm going to do this. I know it's a half an hour kind of talking about theory, but it is a refresher. So I want to like remind you of these things. Let's talk about these two. So let's just talk about circles for a moment. I think I probably need something. Do I not have what I do? I ran out of graph paper. Okay, so I'll just do it here. So if we have a circle, so let's draw a circle. And this is a circle, and let's put down our XY axis. Something like this, right? Okay, great. Okay. Now, a circle is always going to have two things. It's going to have a center and a radius. And let's say we have the center here. And, what we always do for circles is we just call the center, we just give it coordinates HK. We could give it X1, Y1 or X2, Y2, but we're going to give it HK. And part of the reason we're going to give it HK is it's slightly unique. And as soon as we see HK, we'll start thinking about circles, right? So that's a good reason to have a kind of a, it's not completely dedicated to it, but most of the time, if we're talking about HK, we'll be talking about circles. Okay, and then we have another point here, XY. And this point XY, see, I'm actually drawing it in a specific location. Let me just get that comma down. I'm drawing it in a specific location, but what I want you to think is that point could be anywhere. This point is just like a bead that's sort of sliding around, like the circle could be anywhere, right? And the one thing that we know, no matter where we place it on the circle, no matter where we could place it on the circle, that if we were to draw a line from one to the other, that line would have a length of or, because that's how we're making. We set that distance, and then like with a compass, we set the distance, we turn around in a circle. So you could have, like a thumbtack or a nail or something in the ground. You could attach a piece of string onto a piece of paper or something, and then you could just so no matter where we are, that's always going to be or, like this, for example. And what we can also do is we can do this thing, like I'm going to draw this horizontal line like this. And now I'm going to drop down this perpendicular like this, you see, like that. Okay. And as soon as I do that, I have a right angle triangle. And what I can say now, I'm just going to use my coordinate geometry, right? So I'll go down to here. This is my H. I'm going to go down to here. That's the X coordinate, right? So that's my X. Okay. And this distance here is the bigger one, X minus H. And we'll do the same trick over here on the y-axis. So this here is like, if we go across, this is K. If we go across, this is what is this? This is Y. And then this distance here, Y minus K. So this is Y minus K. This is X minus H. Okay. And this is or, okay? And this is a right angle triangle. Okay, so let's just remind ourselves of right angle triangles. Probably know that what I'm going to say. If you know what I'm going to say, that's fantastic. That means that your understanding is setting in. If it's getting boring, then that's really good, because that means you really know what's going on. So this is a squared plus b squared is equal to c squared, or let's write that as, why don't we write that as c squared is equal to a squared plus b squared? Well, applying the exact same logic, or squared is equal to x minus h squared plus y minus k squared. And then that means that that's this here, we're done. And that's equal to or squared, right? That there is the equation of the circle. So the equation of a circle is just Pythagoras theorem again, right? So far we've seen Pythagoras theorem for the distance formula. So this is like really good news, because it means that you're not having to learn like many different things, right? You're learning the same thing in many different ways. So if you can actually spot that this is the same thing being given to you in a different way, then you're doing so much better than someone who doesn't realize that, because the person who doesn't realize that has more things to remember. Okay, so that's why maths is easier than other subjects in some ways is because it really compresses when you understand. That's why it's so important if you can to understand what's going on. Okay, and then the last thing I'll say is see this x minus h squared. See what we could do, and I'm going to get straight into questions now because it's too long not doing that. So r squared is equal to, I could multiply everything out. So this would be minus 2hx plus h squared plus y squared minus 2ky plus k squared. And then I could say, well, that's x squared plus y squared. So I get rid of those. And then I could say minus 2hx and minus 2ky. And then I could take plus the h squared plus the k squared, minus the r squared now is equal to 0. And then I could make a silly choice and say, well, why don't I introduce a new thing, which I'm going to call g, and I'm going to set that to be minus h. And I'm going to take a new thing, I'm going to call it f, and I'm going to set that to be the minus k. And the reason why I'm going to do that is because then I'll get rid of these minus signs, and I'll finally have x squared plus y squared plus is equal to 2gx plus 2fy. And then what I'm going to do is I'm going to create this new thing c, and c is going to be equal to is going to be equal to g squared plus f squared minus r squared, basically. And why would I do this? Well, what I'll say to you is that the reason why you'll do this is exactly the same thing. You see, we've got two different versions of the equation of the line. And in fact, when we were doing the distance, when we were going to apply like this formula here, we even needed the version of the equation, which was like ax plus by plus c is equal to 0. In other words, bring everything over to the left-hand side, have an equation of a line formula where everything is over on the left-hand side. So sometimes you just want to have different versions of the same formula. And all I'm saying here is that when it comes to the circle, we've got two things. And the last thing I'll say is that this formula here, the tangent to the circle through a given point formula, you use that very sort of rarely. Sometimes students sort of use it, but I think it's kind of, sometimes that's just like kind of like just like shot in the dark type of thing. And then you don't worry about this section. That's not on Leaving Cert Maths. Okay, so that was 35 minutes of like a recap of what we mean with the formulas in coordinate geometry, like deriving them, trying to understand them for not only the line, but also for the circle. And what we're going to do now is we're going to tackle some questions. And then what we're going to have to do is have this formula book, like kind of right here. And then what we're going to do is we're going to look at a question, and then we're going to decide, okay, what do we need to find here? And let's go take what we need, and we're going to write it down here. And then we're going to start to sub in some numbers. And I'm going to be telling you as we go when we hit the low partial credit, when we hit the high partial credit, and when we hit full credit, okay? So the first one is like find the equation of the line through 0, 2 with slope equal to 3. So we've been asked for the equation of a line. We've been given a point and a slope. So we're going to go down to find the equation of a line formula. Which one do we use? Well, this is the one with the x1 and the y1. So this is the one into which we could put a point. So we're going to use our formula is y minus y1 is equal to m times x minus x1. And we have now properly diagnosed what kind of question that is. And let me just do one thing. Let's say if I say y minus y1 is equal to, the slope is 3, right? 3 times x minus x1. This now is the low partial credit, 3 marks out of 10. So if you move on, you at least, you got 30, maybe this was your worst question, getting 30% on one of your worst questions. That's pretty good, right? So you could just stop there, but we're gonna go on. Something that I do is I go over and like start labeling in the question. In fact, even doing that would be enough to get you 3 marks out of 10, probably, right? Okay, so now I say y minus y1. What's y minus 2 is equal to 3 times x minus 0. That's y minus 2 is equal to 3 times x. And you know what? I'm just going to get the y on its own on one side. Now I'm done. Okay, quick find the equation of a line. Okay, that's the equation of a line. Yes, that's what I've been asked for. Oh, sorry. This here would be 7 out of 10. In fact, it might even be 10 out of 10. This here is the 10 out of 10. Right? Maybe, like it could only be putting in 1 that gets it at 7 out of 10. Okay, so find the equation of the line through 2, 5 with the slope equal to -0.5. Okay, so again, it's going to be y minus y1 is equal to m times x minus x1. So diagnosing will be like, we were asked for the equation line. This would be super important to get started off. This isn't like, this shouldn't be too taxing. Like this shouldn't take too much energy. You should just be kind of being able to categorize it's, this is coordinate geometry. They're asking about the equation of a line. The formula we need is that one. Okay. So now I put in y minus, and I label everything x1, y1, m. So y minus y1 is y minus 5 is equal to -0.5, and then x minus 2. And I just multiply everything out. So y minus 5 is equal to -0.5 times x, -0.5 times plus a 1, and then y is equal to -0.5 plus a 1, and then plus a 5, and then y is equal to -0.5. Sorry, I forgot my x there. -0.5 x plus 6, and now I'm done. Now, incidentally, maybe if we wanted to have everything over on the right-hand side, well, we'd have to multiply across that too. 2y is equal to -x and then plus 12. Then I bring over x plus 2y plus 12 is equal to 0. So it's another way of writing the same. And then this one, we would be able to use that, for example, in the distance formula if we had to do that, right? Or in the perpendicular distance from a point to a line formula if we wanted to do that. So that's just an example of how we could take the same equation. This is like if we're given this, then we can say this is m immediately. This is c. This is the y-intercept. This is the slope. So we know it's like 1, 2, 3, 4, 5, 6, and it's got a slope. So we know it's like that. That's a way to quickly extract from the equation some key things like slope and intercept. But this one here, to represent it in this way, is going to set us up for being able to use this formula. If we were asked, for example, how far is this point here, x1, y1, away from the line, then representing it in that way would set us up to do that. Okay, great. So it says now, we have a line y is equal to 2x plus 1. And what I always find is that it's always kind of great to sort of like draw these things. So let's say it's a 1 and it's got a slope of 2. So maybe let's say it looks like that. Don't have to be too accurate. And now we've got the point 2, 3. So 2, 3 would be like here, let's say. Something like that. Let's put it here. Again, it doesn't have to be accurate. And what we want to find is the slope of the line that's perpendicular to this one, and that goes through that point there. Okay, so we want a perpendicular line, and then we want to get basically the equation of that line. So to get the equation of a line, we're going to need y minus y1 is equal to m times x minus x1. And we're after this green line here, right? So we have the point 2, 3. So already I could sub in y minus 3 is equal to m times x minus 2. 3 marks out of 10. I'm imagining a scenario where you really are lost, right? And you're like, oh, I have no idea how to do this question. Well, why not just do this bit? Because we know it's not correct, but this is part of the answer. And you put down part of the answer, you get 3 marks out of 10. And like 3 marks out of, you must get these partial grades if you're unsure, and you should not get 0 out of 10. Like just make sure that you just sort of never get 0 out of 10, if that makes sense. Like write something down that is appropriate to the question. Even though you know that it's not the full answer. If it is sort of basically on topic, if it's relevant, then you're going to get marks for it. Okay, so just make sure you get that. Okay, and then we also need this perpendicular bit, and perpendicular to this line M1 is equal to 2, and this line here M2 is equal to, well, what's M2 equal to? And it's by doing this stuff here, by like drawing the diagram, by thinking that it jogs the memory. The second formula, the second clue that we needed was that the perpendicular slope, when we multiply that out, that if we multiply the slope of the first line by the slope of the perpendicular line, that we get minus 1. So here m is equal to 2, and because that's a 2, so when it's written as y is equal to mx plus c, we can quickly, whatever number is in front of the x, just the coefficient of the x is the slope of that line. And this 2, well, the 2 m1 is equal to 2, but it's also equal to 2 over 1. And what this formula is really saying is just this: the perpendicular slope is the same thing, but just flipped upside down. You see, if you take, let's take a fraction, let's take 5/7. Now, what would we have to multiply by 5/7 to get a 1? To get a minus 1? Well, let's just say to get a 1, first of all, forgetting about the minus. Well, it's the same thing, just turned upside down, because the 7 cancels with the 7 and the 5 cancels with the 5. And then to get the minus 1, we just have to multiply it by a minus, you see? So that's why it's always like the perpendicular slope. Once you get the slope, flip it upside down and make a minus. Wouldn't believe how many people make a mistake like that. And like that's an important thing to kind of just sort of maybe just take a moment to talk about. Why do people make a mistake with something like that? And the reason why they make a mistake, if this was all they were asked, if they were just asked, like, take 1, turn it upside down, and get, then put a minus in front of it. Like, if that's all they would ask, then they wouldn't make the mistake. But the fact of the matter is that they're asked this in the context of a larger question. And when you think that you don't understand the big stuff, you make mistakes with the little things. Your mistakes happen with the little things because you're like, your brain starts to go in many different directions, and you just sort of trip up over your own shoelaces type thing because of the state that you kind of get into. So maths is always about doing little things and staying kind of calm and doing things that make sense and just trusting that probably you'll figure it out. Okay. And you probably the thing, like, for example, here, let's say I didn't quite know what to do, but okay. So now what we're saying here is that our M2 for this second line is equal to minus a half. So we have y minus 3 is equal to minus 1 times x minus 2. We're done, except we just have to tidy up. This would definitely be 7 marks out of 10. In fact, that might already be 7 marks out of 10 here. And then this might be then y minus 3 is equal to minus a half times x and plus 1. X is missing, 1, and then y is equal to minus a half times x, then plus a 4. And that's the answer then. Okay. So a perpendicular distance from the point to a line. Okay, so this is the line. And this is the point. So the perpendicular distance from the point to the line, which formula are we going to need? We're going to need this distance here, the distance from a point to a line. So, or the perpendicular distance. The distance will always mean the perpendicular distances, because as I said, there's many distances, but the shortest one is the perpendicular distance. So let's write down the formula. D is equal to ax1 plus by1 plus c all over the square root of a squared plus b squared. Let's draw a quick diagram. So imagine here's the line ax plus by plus c. Here's the point x1, y1. So then equal to 0. And so what we have to do now is we have to go in, we have to say a is equal to 2, b is equal to minus 1, c is equal to minus 5. Now, if you were doing the exam and they put the minus y first and the plus 2, they do things like that. And then people go, oh yeah, a is equal to minus 1, b is equal to, then you're wrong, right? So be prepared that, even to get into the position of being able to apply the method or the formula, you need to do some sort of, like, I'd call it like sort of housekeeping first. So you have to kind of take the question and just prepare it to get it ready for launching into using the method. And they catch a lot of people out because they just go straight to the method, right? So little thing, they're only tiny things, but this is where your mistakes come from. And so we have our A, B, and C, and then we have our X1 and Y1. So this is our X1 and Y1. And you know what? D is now equal to, I'm just going to read it off, 2 times 3 plus, what is it? B, which is minus 1 times 4, like minus 5, all over the square root of A squared plus B squared, which is 2 squared plus 1 squared. I don't care about the signs because I'm squaring everything, so I can just drop the sign as soon as I'm squaring things. Square root of 6 minus 9. What am I talking about? Square root. The absolute value of 6 minus 9 all over the square root of 5. So that's the absolute value of minus 3 over the square root of 5. And the point about this is, as I said, with distance, we never care about negative. So this is just, we take the positive value. If this happened to be a plus, then this would just not do anything, right? But the absolute values will always make whatever's inside into a plus. That's the distance, 3 over the square root of 5. We're not going to divide. We're not going to work out what the square root of 5 is in decimals. This is a perfectly nice answer the way it is. Okay, and then there's the example to find the angle between the lines. You know, I'm going to leave that one because we haven't looked at that formula. It's just another formula. But I want to get on to some other kinds of questions. Okay, so the next one is to find the center and radius of the circle. So we're now on to circles. Center and radius of circles. So we see the way we're given this, they're talking about circles. So let's go over to this section here. Where's the relevant formula? Well, it's going to be this. So I'm going to immediately write that down. X minus h all squared plus y minus k all squared is equal to r squared. And what do these mysterious h's and k's and stuff mean? Well, h and k means the center, and then that would be like some point on the circle, and this would be or here. Okay, so what have I done? I'm looking for the center, and I'm looking for the radius of this circle here with this equation here. And I've selected the correct formula to use. Brilliant. I've diagnosed the problem correctly. Now, if I start to sub in some numbers or get anything at all, I'm going to be getting marks. So far, I probably don't have any marks just for getting the right formula. It's touch and go there, but usually you don't get marks. You have to do something in order to get some marks. So let's just write this down. Okay, so let's just write this down directly on x minus h all squared plus y minus k all squared is equal to r squared. Well, let me take that 36. That 36 is 6 squared. All right, so that means that r squared is 6 squared. That means that r is equal to 6. Brilliant. 3 marks out of 10 already. Okay, maybe even more. Maybe this might be one of those where it has a mid part, so it might be 5 marks out of 10, right? Okay, here, minus 3 is equal to minus h. So that means that 3 is equal to h. And then plus 4 is equal to minus k. So that means that minus 4 is equal to k. So hk, which is the center, is equal to 3 minus 4. Okay. So the center is 3 minus 4, and the radius is equal to 6. So, you know, it's kind of touch and go, but it could be, you know, finding one of them is like finding r is equal to 6 might already be like finding 1 out of the 2 is already the high partial credit, right? Or having written 6 squared might be enough for the low partial credit, right? So, right. And the final one, and I think we might get to look at some, maybe we'll see if we get to exam questions. We don't really have to do exam questions because as I said, it's sort of refresher and stuff. But the circle might be given to you in this form here, like so. So the circle can be given to you like with the brackets or without the brackets, with everything multiplied out. And in that case, we need to use this one. Okay, so the formula that we're going to be using is x squared plus y squared plus 2gx plus 2fy plus c, is equal to 0. Sorry, of course it's plus c, sorry. Plus c is equal to 0. Okay, so we have the right formula. We've properly diagnosed the problem. We're being asked for the center and the radius, okay? The center is minus g minus f, and the radius is g squared plus f squared minus the c. Okay, so what I'm going to do is directly underneath this thing, plus y squared, I'm going to write plus 2gx plus 2fy plus c is equal to 0. And I'm going to be able to extract from this that 2g is equal to minus 6, 2f is equal to 8, and c is equal to minus 11. You see how easy I make life for myself if I'm doing this in a methodical way. right? So what I did in the first stage of this was like, what even formula am I going to use? Forget about the numbers. Just where do I start with this? And you go over and you're like, well, it's a circle. So we go to this section. There's two possibilities, and it's not the first one. Okay. It's the second one. So I gather all together, all the tools that I need, and I lay them down here, and I'm finished with the diagnosis. Now, the next thing here is all kind of just about layout, right? And what I'm all about is it's all about being smart, right? I mean, being smart in the sense of like not being super clever, but just being like, how can I do this with the minimum effort, so that I'm not strained in any way, right? To be sort of strategic, right? Okay, so I just sort of lay these things down like this, and then I can just sort of match them. You say, I just match them like that. Okay, this tells me that G is equal to -3. It tells me F is equal to 4. And it tells me, well, C is equal to -11. I already knew that. And now I'm like, okay, now that I have my G, F, and C, how can I find my center? So what is my center? Well, my center is -G minus F. So it's -G, which is -3. So my center is 3, and -F, F is 4. So 3 minus 4. And people just it's just mad when you see it, but people make mistakes. They just take this -6, they throw it straight there, they take the 8. And what they're doing is they're going up the stairs and they're trying to jump like, and they just fall. You have to be sort of just very, very methodical, like kind of robotic, right? At the beginning, we're not robotic because what we're doing is we're sort of searching, right? Like, what is it? And then we're kind of thinking and stuff like that. But as soon as we're like, this is how we do this problem, and now I'm going to like solve everything, that's when we sort of have to turn into a robot, right? And then that's when we're going to start to just sort of like march towards the answer. Okay, so we have the center, perfect. So we have part of the answer. Oh, incidentally, anything from this, so 2G, like this bit or this bit or this bit, that would be enough for 3 out of 10. This is definitely like probably 7 out of 10 type thing. Like you're already up there. And what about the OR? Well, the equation for the OR is going to be the square root of G squared plus F squared minus C. So it's the square root of -3 squared. Now remember, you can write down -3 squared, but remember squares get rid of minuses. So you could just write down 3 squared plus 4 squared, and then minus C, but it's minus 11, so plus 11. So that's the square root of 9 plus 16 plus 11, which is the square root of 25 plus 11, which is actually the square root of 36, which is actually 6. So we have that the radius is then equal to 6. So we have a center of 3 minus 4 and with a radius of 6. And I think that's what we had last time, wasn't it? Yeah, 3 minus 4 and radius was equal to 6. So last time we had this way of expressing the equation of the circle, and we had the same way of expressing the experiment and a different method to recover both of them. Okay, so we're almost there. And the distance between 2 points, so x1, y1, x2, y2. And what I'm going to demonstrate for you now is a way that you can actually do your study. And we can do questions super fast. Okay, so what's the formula? We're looking for the distance formula. D is equal to the square root of x2 minus x1 all squared plus y2 minus y1 all squared. So that one there, okay? Then we have the midpoint formula. Midpoint is going to be x1 plus x2 over 2, y1 plus y2 over 2. We've diagnosed everything correctly, and I see the x1 and the y1, so I put the x1 here, the y1 here, the x2 here, the y2 here, same over here, and then do some maths, and then after that, I'll be down at the right answer, okay? So you do all of the thinking part, and the part that's lengthy, that has to be done very methodically, carefully, the sort of robotic part, just don't do it. You can go through an entire exam paper and just diagnose every single part. And if you do that correctly, you're basically got to the level where you've diagnosed everything correctly. Every question is like basically set up for the win, and you can another time you can go to doing this work, which is really this methodical work. Okay, so now we're going to say that a point AB this line segment AB. So this is the point AB. We want to divide this in the ratio of 1:2. Okay, what formula do we need? We need this formula here. So it's sort of like bx1 plus ax2 over b plus a, by1 plus by2 over b plus a. So this is the formula, and then the question is, so what we want, we have the segment A, B, and then the ratio of 1:2. So we need like, oh, this would be the 1 and this would be the 2. And the question is, and this is going to be my x1, y1, and this is going to be my x2, y2. And we can see that like either, so we're going to have an A and a B, and they're going to have to be this like this 1 and 2. So which one is the 1 and which one is the 2? Well, basically what I do here is I think about like balancing something that doesn't have the center of gravity in the middle. And what we're going to have here is the heavier weight on this side, which means that the number multiplying by that point there, which is the B, has to be equal to 2. We'll do this again, but this is the only place that you can go wrong with this question, is choosing these incorrectly. If you were to choose it incorrectly and work it right out to the end, 7 marks out of 10. So if you do A equal 1, B is equal to 2, that's the only mistake you make, then you get 7 marks out of 10. And the last, very, very, very last thing I'm going to do, because we're just out of time, I think after that I have some, so this one was getting a surf from a graph, and I had a quiz we don't have time to do, and then I just got into exam paper. So the last one is saying, what's the intersection of a line and a circle? So we have a line, y is equal to x plus 1. So this is m is equal to 1, c is equal to 1. So that's going to be like something like this. It goes to the point 1 with a slope 1. X squared plus y squared is equal to 25. So that's a circle. That's the same as x minus 0 squared plus y minus 0 squared is equal to 25. So that's center 0, 0 with a radius of 5. So go 1, 2, 3, 4, 5. Now make a circle. Next class is just starting. Sorry, I have to be quick. So then it's like this. So it's sort of like, where do these things cross over? Where do they cross over? Here and here. This is the intersection. How do we do it? Well, we have y is equal to x plus 1. And then we write down x squared plus y squared is equal to 25. And you know what? Y is equal to x plus 1. And so we say x squared plus, and not y squared, x plus 1 squared is equal to 25. We get a quadratic. We solve the quadratic. We get 2 values for x. That gives you 2 values for y. This is a simultaneous equation. We'll do it another time. But okay, so that's that. So I don't know if I have a recap, but I don't have a recap. So so that was just going through a few examples there. And then tomorrow we'll go to trigonometry. So I hope that was helpful. And I got to stop now because the next class starts. So then I'll see you all then tomorrow, and I'll send on the video of this later. Okay. So see you then.